All right, just a couple of thoughts. One that's sort of deeply cosmic and another one that is fascinatingly disturbing, I think. You'll be the judge of this. Consider a couple of fundamental facts that has been gleaned in the past 60 years. That the ingredients, if you had asked your chemistry teacher 50 years ago, once you looked at that mysterious chart of boxes that sat in front of your class, the periodic table of elements, where did those elements come from? The chemistry teacher would actually not have an answer for you. They'll say, well, we dig them out of the earth. That's not where they come from. It took modern astrophysics to determine the origin of the chemical elements. We observe stars. We know what goes on in their center. They explode, laying bare their contents. And what we have discovered is that the elements of the periodic table, that which we are made of, derive from the actions of stars that have manufactured the elements, exploded, scattered their enriched guts across the galaxy, contaminating or enriching gas clouds that then form a next generation of stars populated by planets and possibly life. And so, when you look at the ingredients of the universe, the number one ingredient is hydrogen. Next is helium. Next is hydrogen, helium, oxygen, carbon, nitrogen. Those are the top ingredients in the universe. So you say, well, okay, that's kind of cool. Well, and you look at Earth, because we like thinking of ourselves as special. We say, oh, we're special. Well, what are we made of? Well, what's the number one sort of molecule in the body? It's water. It's water. Well, what's water made of? H2O. Hydrogen and oxygen. Hydrogen and oxygen. In fact, if you rank the elements in the human body, with the exception of helium, which is chemically inert, useless to you for any reason other than just to inhale it and sound like Mickey Mouse, you can't die from helium unless that's all you breathe. Number one in the human body is hydrogen. Matches the universe. Number two is oxygen. Matches the universe. Number three, carbon. Matches the universe. Number four, nitrogen. Matches the universe. And for each of us, the fifth element, other, is the same in both places. Okay? Other. So, we learned in the last 50 years that, of course, not only do we exist in this universe, it is the universe itself that exists within us. And had we been made of some rare isotope of bismuth, you would have arguments saying, hey, we're something special. But there are people who are upset by that fact, saying, well, that mean we're not special? Well, I think it's special in another kind of way. Because when you look up at the night sky, it's no longer we're here and that's there. It's that we are part of that. And that association, for me, is actually quite enlightening and ennobling and enriching. In fact, it's almost spiritual, looking up at the night sky and finding a sense of belonging, given what we've learned about the night sky. And so now we have ourselves. Now, are we alone in the universe? We're made of the most common ingredients there are. And our chemistry is based on carbon. Carbon is the most chemically active ingredient in the entire periodic table. If you were to find a chemistry on which to base something really complex called life, you would base it on carbon. Carbon is like the fourth most abundant ingredient in the universe. Isn't that rare? You can make more molecules out of carbon than you can all other kinds of molecules combined. So, if we ask ourselves, are we alone in the universe? It would be, in spite of my diatribe about UFOs, I tell you in the same breath that it would be inexcusably egocentric to suggest that we are alone in the cosmos. The chemistry is too rich to declare that. The universe, too vast. There are more stars in the universe than grains of sand in all the beaches of the world. There are more stars in the universe than all the sounds and words ever uttered by all humans who have ever lived. To say we're alone in the universe. No, we haven't found life outside of Earth yet. We're looking, haven't looked very far yet. Galaxies this big, we looked about that far. But we're looking. And how about life on Earth? How is it hard to form? Just because we don't know how to do it in the lab doesn't mean nature had problems. So it may be, given that information, that given the right ingredients, which are everywhere, life may be inevitable, an inevitable consequence of complex chemistry.